Hello everyone, myself Mukund Ramprasad Soni. I am student of Arihant College of Education. I am pursuing B.Ed second year.
This video is for those students who are pursuing 10th grade SSC Board Maharashtra. Before watching this video, a student should be knowing division, multiplication, squaring, handling with the exponents, basic ideas of the physics such as motion, velocity, gravity, Newton's law of gravity, etc. So let's begin. Students, can you recall what is the value of acceleration due to gravity? Take your time. If you are not getting answer quickly, you can pause the video, and once you get the answer, you can resume it to check your answer. I hope you can definitely get it. Let's try. It's 9.8 meter per second square. Keep in mind, unit is most important here. Just writing answer 9.8 means a number will not help us to understand what exactly that number stands for or what is the meaning of the number if we do not describe its unit. Unit helps us to know this value is related to acceleration due to gravity. Do not forget. Now, let us try again. If you did not get answer from the previous one, try this time. Do you recall? What is the formula for force of attraction given by Newton? He had said the force of attraction between two given masses, right? Think, this is an hint. Correct? Few of you definitely had got the answer. That is F equals to Gm1 m2 upon r square, where r stands for radius of the planet. G, capital G, stands for universal gravitational constant. This have some constant fixed value which do not change. M1 and M2 are the mass of the objects, and putting the values in this formula will bring us the answer for force of attraction given by Newton. Now, do you know in our textbook the same formula is written in another form? Are you able to compare? Where is the change? Observe carefully. And it also given in one more form. Now this may make you a little confusing. Why there are three different letters at the very same place in a red color? Are they different or they are having same significance? So yes, my dear students, all these three letters have a same significance. They are meant to be measuring the distance between the two objects. You can represent it with a D. If you are standing on the surface of the planet, then the radius of the planet. And if you are orbiting around the planet like in some satellite, like a moon, so you will measure the radius of a satellite. These three formulas and their workings are same, only symbolical representation for the purpose of a use is a different. So what I'm trying to say all is they are having same meaning. They can be replaced by each other. So students, do you know what we are going to learn today? Before that, I have one question in mind for you. What is the figure of the earth called, oh, but obvious, we all know, starts with yes, isn't it? Let's check your answer. It's known as geoid. Geoid is a different shape as that of spherical shape. We will discuss that today. That is what we are going to learn today. Today, we are going to learn 3 different points. All are interlinked with each other. So, during the lecture, do not lose your attention. Now, let us see what those 3 points are. The first point is Earth's gravitation force. Earth's gravitational force. Second point is Earth's gravitational acceleration. See, only force is replaced with the acceleration. That means they are closely related to the gravity of the earth. Something have to do with it. Next point is, and the last point for today will be the variation in the values of g. The small g, which means value of gravity, you all know. We mentioned it earlier. Yes? Okay. So let's begin. Let's learn about Earth's gravitational force. Now, have you ever observed? Will the velocity of the ball thrown vertically upward remains constant? You will have to think about the ball when you throw it upside. I hope you like to play games which includes the ball. But of course, not the rolling balls, the balls which we have to throw. Playing game will keep you healthy, but learning it with the science will help you to understand the complex ideas of the game, even though you will be able to calibrate your actions and moves. For now, we will keep that aside, but we will look into the vertically thrown ball. Will it change with the time? That's its velocity. When we throw it upward, will it change its velocity when it will move upward with the time? Like as the time goes ahead, the speed of the ball, will it remain same? Think. Or will it be changed? How will it change? And why doesn't the ball move up all the time? I think many of you may have the similar kind of questions about the gravity and the activity you perform in a day-to-day life and how exactly the gravity relates to it. So today we are definitely going to find the answers for them. So when you throw the ball upward, its velocity do not remains constant. Yes, it changes with the time. How will it change? But it will change because when you throw it upward, the earth, the planet, will try and attract it towards its center. That is what is the concept of a gravity. It pulls everything towards the center of the heavy object. Then the force you applied on the ball and the force of attraction towards the center of the earth by the earth will start cancelling out each other. Initially, the force applied by you will be more than that of the force applied by the earth itself. and then gradually this force applied by you will decrease and will go less than that of Earth, and that's how the ball won't keep going with a constant speed and it will change. Now let's think again. When the ball drops down, let us see again how exactly the ball gets dropped down. So, do you see the falling of the ball? Isn't its speed is increasing? Oh, it's bounced. It must be hit to the hard surface. Again bounced. But every time its height is decreasing. And the reason is again somewhere is the gravity. Now, how does it fall down after reaching certain height? So like in a previous example, we saw it had some height when you thrown it upwards, and then it start falling down. And why does it so? I gave you the answer already. That is due to the gravity of Earth, the pull produced by the Earth. Then is there any way to measure this height? Yes, using the formulas of kinetic motion, one can find it out. Like the one we learnt earlier, V is equals to U plus AT. Definitely we will see the example for it in next session. Now, how will you measure the pull of the gravity? Because as I said earlier, the pull of the gravity, if my force is more than the pull of gravity, the ball can move upward. The rockets can go up. The helicopters, the birds, even though the insects, they can fly up if they are able to generate enough force which is more than the pull of gravity. Then they can move up as much as you want. But if we do not generate it, then definitely we will fall down. Now for that, I first need to know how much exactly the force is produced there. Let's look at an example. To find out it, one need to use the Newton's formula of gravitational force. I have called someone to help us to understand how does exactly it works. Oh, here he is. Oh, he's waving hand for you. What is it standing on? Think. Correct. It's a weighing machine. His name is Mahendra, and he is interested to find how much the gravitational pull on it. Oh, he got an idea. Let's solve his problem with the help of Newton's formula on gravitational force. How exactly? Let's check what he says. F equals to G m1 m2 upon r square. Oh, we know that. But now we need to see the calculation also. So don't forget to record the mass of Mahendra. Let's move to the next screen. Now here is the Mahendra again. He is looking for his answer. Now let's help him to find his answer. Now he had gave us the formula F equals to G m1 m2 upon r square, and he had asked our help to find the gravitational force that is basically unknown to us. Now capital G, as I spoke earlier, it's a universal gravitational constant whose values are fixed, do not change. You can memorize this as it is a part of your question. It will be there. You will need it. And that is 6.67 into 10 to the power negative 11 Newton meter square per kg square. Unit can be asked for as an MCQ. So memorize it carefully along with value. Then the mass of the earth, and it's very huge, that is 6 into 10 to the power 24 kg. You all must be knowing it, I hope. Okay, and what was the mass of the Mahindra from earlier slide? Do you recall it? Yes, it was 75 kg. You can measure your own mass and you can replace the mass of Mahindra by your mass. Then you will be able to find the pull of the gravity on you. So let's check. We also need to know the value of R. For a calculation purpose, we use approx value of the radius of our planet Earth, that is 6.4 into 10 to the power minus 6. Sorry, my mistake. 6.4 into 10 to the power 6 meter. See, mistakes happens. We all are human beings. But taking our mistake sportingly and trying to correct it, that makes us more human being, because that shows our ability of fighting back to the failure. And never get fed up with any kind of silly mistakes or failure. You can revise them, you can correct them, and you can achieve the good things in future once you start doing it. Oh, Mahindra is waiting. Let's move ahead. Now let's put the values. The value of G, then value of M1, and then value of M2, and divided by square of distance, that is radius. Now you all can pause the video, do this entire calculation on notebook, or you may use logbooks, or you may use calculators. For timing, I have calculated it for you, but you should check it. You should cross check it. It's 733 Newton. So that is the pull Mahindra had by the earth on it. Now, every object have the pull. That is in fact, that is a fact, right? And who stated that fact first? The Newton. What did he say? He said every object in a universe attracts every other object towards it. Like in this case, Mahindra was attracted or pulled by Earth. And that is what the general sentence of the Newton said, that the force of attraction between two mass bodies is directly proportional to product of their masses and inversely proportional to product square of distance between them. That was the radius, because from the center of the earth and on the surface of the earth, only radius is the amount of distance that Mahindra and the earth had in between. Do not count it from the surface, count it from the center of the body. You know that the Newton's definition about the gravitational force can be twisted and said in the terms of friendship, as my version, something like this: the friendship between two friends is directly proportional to product of their honesty. And we all know that honesty is the best policy. Always be honest with your friends. In return, he will be honest with you. And inversely proportional to square of distance between them. More you go away, more you think of your friend, because you wanted to be genuine with him, you wanted to be with him so that you can spend some good times, you can share your thoughts with each other, respect each other, learn from each other, be as a team. Don't forget, that is what Earth is also doing with the every other satellite, every other living thing, every non-living thing, objects available on its surface. Yes, and that's how they are being a friend. We all are being a friend with each other. Don't forget. Now, let us see how exactly it's applied. So, like, as he said, object gets attracted towards each other. Doesn't it means that the earth also move towards the ball? As like ball fall towards the earth, or it does not? Does it? Have you ever observed the earth moved towards some object like a moon or like a ball? No, it's a fun, it's a joke, right? Yeah, I feel too. But what is the reason? Think on it. There must be some scientific reason behind it so that the ball getting fall back, but not earth is moving up towards the ball. Do you recall, as the moon is also have a spherical shape like our ball, almost spherical shape, but it does not fall on the surface of earth, even if it have a less mass, many times less mass than the earth, but our ball falls down. There must be some specific reason behind it, isn't it? Let's find out the reason behind it. So, reason is the velocity for circular motion around the planet Earth. We all know that moon is revolving around Earth as well as rotating too with a certain velocity. That velocity is called as critical velocity of the satellite. This is a specific velocity using which one can check out the motion of the Earth or other planets around some other object like Earth around the Sun and Moon around the planet Earth. That circular motion, that velocity, if it is given to any object, then definitely it won't fall down. It won't fall down. Eventually, it will be keep moving around it without falling down. And if it is given to the ball, it won't. But as we cannot make up that critical velocity, so that's why it always falls down. Isn't it sad? Yes, let us see again. Now, there is a question, why is the gravity of the earth is always taken 9.8 meter per second square? Is there some reason, or it's just some random number? Think scientifically. There is always some scientific reason behind having such a number very precisely. And now, like, why not 10? It could be very easy to memorize, right? But it's just a 9.8. There must be some reason behind it. Let's check it out. So, to calculate it, we need the formulas of the Newton, given by the Newton, of the forces. First formula, that is the force of attraction between the bodies, that is gravitation, force of gravitation. And the second formula will be the mass into acceleration, our famous favorite one. But here we are considering the acceleration as a g, that is acceleration due to gravity. And we are saying, say, g is unknown to us, where m2 represent the mass of any object on the surface of planet, and m1 is the mass of the planet, where r is the radius of the planet. G is a universal gravitational constant. And as the forces applied by the planet and the object are equal and opposite, then you can see from equation 1 and 2, the F is the same on LHS. We can equate them. M2G equals to G times M1 M2 over R square. Now do you see the same m2 m2 can get cancelled? What is remaining is a g equals to gm1 upon r square, which means m1 is a mass of the planet. In this case it will be a planet of Earth for us, and r will be the radius of the planet. In this case the radius of the planet, that is radius of the Earth for us. So this is our formula. That means the gravity is not independent on the masses of the objects on the surface of the planet, rather than it depends upon the mass of a planet itself and the radius of planets also. Now let's put all the values from the previous example, and now putting into the formula, and you get the result as a 9.77 meter per second square. You can approximate it as a 9.8, but I won't suggest you to do so. Having accurate value is a good thing. But then why isn't it matching to the 9.8? Why there is a variation in between this? Let's check out answer of it. The variation in a value of g. There are several reasons due to which the value of g can be varied. As of now, from the formula, if you see, you will find out that it depends upon the mass of planet. It also depends upon the radius of the planet, and this value still not uniform. Even if we are taking the constant value of the mass, constant value for the radius of the planet, then why isn't it uniform? Why it is different? Reason: first, as I said, it is depend upon the mass directly. So say mass is 10 kg or mass is 20 kg, then gravity will be exactly same as of that. It is just an example. It's not the perfect one. Now we do know gravity is inversely proportional to the square of distances between them. Now compare these two values, that is, first one is with a 10 and 20, and tell me which value is the bigger one. Yes, of course, 20. And m stands in a numerator. So if numerator is bigger, definitely value of g is bigger. Now let's look at another example. The 2 square 4, that is 1 by 4, and the square of a 10, that is 100, is 1 by 100. Which value is bigger in this case, 1 over 4 or 1 over 100? Correct, it's 1 over 100 is smaller than the 1 over 4. That means smaller is the denominator, bigger will be the value of g. So now you can observe the variation through these two ideas. Let's check the first variation, and that is due to the change in a surface of the planet. Can you recall? Say this is the planet of the shape of our planet, which you ideally take it as a spherical one. Now this is the radius, diameter actually I'm showing there, and half of it will be the radius of us. That is, we are taking as a mean radius 6371 kilometer, or approximately 6400 kilometer for our calculation, easiness of a calculation. But I will suggest you not to follow the approx values. Please follow the accurate value. That's why it is given on the screen to you. Now, but as we speak earlier, the planet of Earth is not the spherical one. It's geoid. How is the geoid different than the spherical? Look at here. When you speak of the geoid, geoid is little flapped on top, at the side of top and bottom. Do you see? The diameter from earlier is not matching to the diameter for the new one. That is what is the difference. Equator still is the same, but not at the side of the poles. That's how we can measure there is a difference between the radius at the equator and radius at the pole, whereas the radius at the equator is bigger than the radius at the pole, and that is no small difference. It is around 14 kilometers, approximately 14 kilometers of the difference between them. It's very huge difference. And as we discussed earlier, now can you tell me, out of these two radius, which radius will be able to produce more gravity than the other? Will it be at an equator or will it be at a pole? Think critically. Do think scientifically. Yes, as they are inversely proportional, so bigger is the value, smaller will be the gravity. That's why the pole wins, because pole have a small radius and gets more gravity by the formula. Now these values varies from 0. Sorry, my mistake. These values starts from 9.78 till the 9.81. That is 9.81 at an equator. Sorry, not equator, poles. 9.81 is at poles and rest is at equator. That difference is the major thing here. And see, when I move from equator to pole, it varies. Yes, there is a variation. It is not uniform. Why? Because shape of the earth is not uniform. It's geoid. It's little flat at the pole side. This reason is there why that is less and why this one is greater, even if radiuses are that way, because they are inversely proportional and squared. Now there are other reasons too, like the change in a value of a g due to change in a height. As you move away from the planet, as you move up, the distance between you and the planet increases. And just from the previous example, idea from the previous two examples, you may have understood now, if distances increases, the gravity, correct, decreases. Let's see an example. So the color in a black, that is the radius of earth, and the color in a red, the line, that is the height. Now you know that the aeroplane and the rockets are moving at a different heights, but that height, if we add as a distance between the center of the planet and the satellite or some artificial satellite or aeroplanes, then that will be the actual distance. That means d will be replaced as r plus h, that is radius of earth and the height from the surface and above. That's why they are in the same color. And more is the h, more will be the big denominator and smaller will be the gravity. But for the smaller heights, it actually does not matter much, but for big heights, it really matters a lot. You can check few values from the table. You may pause the video, and for different heights, what is the relative change in gravity, you can find out, or else you can read it in your textbook in a chapter at page number 8. So I hope you liked it all. Let us see what have you learned today. So today we have learned 3 different points. We learned through 3 different points. First point is the Earth's gravitational force, that is the case of a Mahindra. Then the Earth's gravitational acceleration, why is the value is 9.8. Then we later found that it is 9.77. But we do find one interesting thing, that is it is not same. Why there are different values? Because there is a variation in a use of radius, and shape of the planet is not same. Even though you may go away from the planet or come closer, that also changes the value overall. There are few questions for you. These questions are also available in a Google link. Now there are some questions added in a description below. Find out the link and fill your answers there. Your homework will be find out more about the shape of the earth and its physical properties, like as a density, a temperature of a environment, and what is there in environment, and the shape and the radius, volume, mass, various properties, physical properties. Okay, on the internet you can take as a link Wikipedia, or you can use other resources as well. I hope you have enjoyed the lecture. Thank you everyone. That's it for today.